Okay, guys. So this is the last first session. So with this, we will be completing the first cycle of classes. I hope that you enjoy the other classes. I think you first got AI, after got robotics, after that arts, and this is the last one, science. I'm going to explain why I made this movement. But overall, I hope that you're enjoying this team. This is a project that as I mentioned on the opening ceremony, this is a project that I really enjoy and a project that I really put effort and heart into. And my top priority is for you to feel comfortable and to learn. I have no hard feelings regarding you doing other stuff. If you want to be in your phone, well, that's up to you. I won't tell you anything. What I'm going to ask you only is just be respectful. That's a cool X-wing. That's a cool X-wing. Sorry. You're good at origami. Sorry. I take no hard feelings into you doing other stuff, but I'm going to ask you respect. At the end of the day, it's not respect for me. To be honest, I don't care if you're not listening to me. I ask respect for your partner. On the feedback, I have seen that some of you have write down that you are feeling uncomfortable when someone is not paying attention. So if you're not going to pay attention, don't worry. Just get to the back, do your stuff. I'm okay with that, but just don't talk that loud and don't bother your peers, okay? And I mean, I think you know me. I'm Alan Guzman, I'm the team director, I'm the science teacher. I am 23 years old, graduated biomedical engineer from Tec de Monterrey back in Mexico. I graduated last year. What else I can tell about me? I work as a 3D printing lab engineer, which effectively is a prototyping engineer at Thermo Fisher Scientific, that's my company. And I really love languages. I know how to speak Spanish, obviously, the mother tongue, English. I have a B1 on French. I know a bit of German, and I'm studying Korean as of now. I really love cultures. I really love to hang out with my friends, with my international family, which this is my international family. This is my 4th year here as a UNESCO Center for Peace staff member, my 2nd year as this team director, and each year my goal is to improve and to impact at least the life of one of you. If I can give you an insight of how life is going in the adulthood, or how I choose my career, or how I make something, well, that's a win for me. Just impacting one of your life, that's enough. I mean, at the end of the day, it's more life that I impact, but just one, that's what I like to do with my life. What else I can tell you? This program was planned with my whole heart and for you. This is for you and only for you. This is not about me or my ego or the ego of my staff. This is to get, as I mentioned, impact on the life of each one of you. So if you don't like my class, I'm totally okay with that. Everybody has their interest. If you're not interested on what I'm going to present, that's totally okay. Then you will enjoy more Eva's class or Andy's class or Eman's class maybe later than next week. But yeah, that's the little introduction that I want to make with you. And I would really appreciate if you share with me your name, your country, why you choose a STEAM, and also if you know the career that you're pursuing, that will be very helpful for me so I can drive this class towards your interest, even though it might not be designed for your interest. I'm gonna drive it through. That's why we're bringing experts in topics. I know how to drive. This is my element. I know how to move the topics around, so I can teach you what you want. So if we can start over here, then we move here.
My full name is Nathan Awakan. I'm delegating for Ethiopia. And why I'm in STEM? I'm in STEM because my interest is in math usually want to watch entertainment content. I usually want it to also have an educational side, and if it has science in it, I usually have no problem watching it. I try my best to learn something from it, and then I also find that it helps me in school again, and then that also takes me back positive feedback. And I thought that if I had to choose between the three options I got, STEAM would be the best one. I'll go ahead and say in terms of career, I really want to have a choice before I'm in further education, but I don't have a choice because I don't really I want to first fully understand how much effort each path might take, and if I think that I have enough to do that, and in short, I'm still figuring it out in terms of career. That ends it for me. And
Yeah, appreciate it.
Hi.
Also, before continuing, if you are not comfortable with sharing things, just tell me your name and your company. I'm not going to obligate you to do something you don't want.
Okay. Hi, my name is Maria Jose. I'm from Colombia. I choose STEAM because also I love everything that has to do with science, physics, math, and I want to study mechanical or mechatronic engineering.
Okay, okay. Yep.
I'm Luisa Tirando. I am 22 years old. I mean, I am the oldest person in this group, but it's interesting because another perspective of the STEAM program. I choose the STEAM program because I don't have choose really. At least I have a scholarship to a physics program. Is it STEAM or STEAM?
Yeah.
No choice. I am a mechatronic engineering student, and I am software developer too. In fact, I really like all topics because the STEAM is my life. Since I was a kid, I like these topics, robotics, AI, everything with the STEAM. At the moment, I think I like explore because it's funny. It's a funny thing to see the other perspective of my partners because they are younger than me, and it's really funny how to teach the topics about AI or the other technologies. So that's all.
Thank you. Got it? Okay. Thank you.
My name is Matias Agarza. I'm from Peru. I'm joining to this new program because I want to try something new, and also I like technology and how we can use that to help people and improve our communities. And there's I joined this new program.
Okay.
I'm Adriano. I'm from Peru, and I joined STEAM because I want to know more about engineering, and also, more specifically, because I just got admitted at the university on my country at biomedical engineering, so I'm looking for answers to that career because next year I'm start studying.
We will love this class. Thank you.
I'm Tadeo from Peru, and I choose STEAM because I like the topics that we're going to talk about in the program, and I'm going to study astronomy.
Okay. That's a good one. Let's go back.
I'm Leslie. I'm from Peru, and I choose STEAM because I love science, and especially maths, physics, chem, and biology. And I want to be a doctor.
You want to be a doctor. You will also love this class.
My name is Kristen. I am from Guatemala. And
You want to share it?
I choose this program because first we didn't have like when I get into SCAM, I didn't really know about all about this. So STEAM, I
thought that it was the best option.
Okay.
And in the future, I want to study biochemical engineering. I don't know how to say it.
Sorry. Okay. I think, well, Shirin, you too.
I am Shreyan, I'm 20 years old from India. I honestly failed every science class in school, but I love the other parts. PEA, that's the part I love. S and M, not my bit, so I'm here to learn from Alan.
Okay.
Because, yeah, so that's why I'm here.
Yeah.
I'm Sean and I'm from Ghana. And I chose STEM because I like math and science.
Okay. Interesting. Yeah. Okay, don't worry. So, I really appreciate your comments. First of all, it might be embarrassing, but a quick shout out to Luisa. She won the scholarship that we create, and sorry about that. No, I just remember that, and I'm going to tell my team to remember everybody, not about you, but about the initiative that we have. And we have a pretty, like in here, we have 2, 4, 5 guys and 7, 6 girls, delegates. And I think it's important for you, especially for you as men, to know that women in STEAM struggle because they are underrepresented. In this case, I'm very happy that we have more women than men. Not because I'm giving them an advantage or my team is giving them an advantage, but I mean, history talks a lot, and it's important to give them the opportunity. That's why we come up with this initiative, and we will expand it in the future. I really hope that you enjoy the program. I know you don't have a choice because that's the scholarship of my program. But yeah, for you guys, please do not be rude with girls in STEAM. They are as good as we are, and you are as good or better than we are. And just be cool with them and make them feel welcome. Like at the end of the day, in STEAM and science and technology and all areas, politics also in the humankind and society, it's important to let everyone know that it's a safe space. So please contribute to that. That is a thing that I would ask you to do in the future, and please continue to make this feel amazing. I really enjoy seeing that girls are getting more and more in STEAM, so congrats on that. I know it's going to be hard for you to study an engineer or something in science because it's hard for girls, but you will pull that out and you will do it amazing. You are very, very capable of us. We are like people. It's not men or boys, it's people. And you will do it amazingly. So, okay. Regarding my class, it's called science, but at the end of the day, what I'm going to teach you is critical thinking with the expertise that I have, which is biomedical engineer. You will see that I'll be jumping around several topics. You will see that I might not have a plan, and I'm just wandering around this topic and that topic and just saying nonsense. But I promise you that this has a purpose and this is well planned. I'm gonna divert from the class just to match your interests. So I hope that you enjoy it. First of all, who loves math? Okay, are you good at it? Man, I was good at it. So, what is math? For you, what is math? Everybody can participate. There are not bad answers. If you told me that math is related to fish food or to the cafeteria and the vegan options, that's totally cool. You just tell me whatever is on your mind. I appreciate knowing what's on your mind so we can shape and mold what's going on there to the right path. Okay, so just please participate. Go ahead.
I like mathematics. I'll go ahead and start with what I think mathematics is. Mathematics is the study of numbers, shape, geometric relations. Basically, it covers a lot of things, but the side that most people would be familiar with, I think, is mathematics is how you can manipulate numbers to involve related with interactions in real life and theories.
Okay.
I like mathematics because it lets me try different things on my own and also learn different things and see how other things work together with that. And I also like mathematics because I like trying to find a way to acquire a piece of information using other things. And since that's related with, I think that's related with critical thinking. And that's one thing I could say.
Okay.
That closes for me.
That's a good one. Let's go with Lisa and then.
I think mathematics I think is a universal expression. Everything is the same math in China, like in Colombia, like in Ghana. The math is like a universal language of the world was created. Everything can be expressed through the math.
Okay. Thank you very much.
I love maths because like everything we know that is created by human is created using maths, and it is used for everything. As I said, it is so important. It's like we should know maths as a language more than a thing or we learn at school because we will use it on everything, practically on everything we do.
Thank you.
For me, math is like a language that helps us explain and it helps us show how everything around us works. And like, I like it a lot because it has like it has a way of working. Like you can't have something wrong because it has to give you like an exact answer for me. So that's why I really like it.
Okay. Any other comments on that? Yeah.
I think maths is about business, like money coming in, money going out, plus minus,
Yeah.
percentage, equity.
Okay. No bad answers, as I mentioned. Thank you. I mean, I'm surprised you're gonna take my job in the future. But okay, so do you know what's that?
Calculus.
Calculus.
Limits,
Limits, derivatives. Any other guess?
Integral.
Integral. Yeah. Any other guess? What does it mean? I mean, I can explain you what's going on in there, but what does it mean?
Formulas?
What?
Formulas?
Formulas? Anyone? Trigonometry? Algebra. Yeah, those are correct answers, but like think about it. What does it represent? No? You don't have an idea? In Spanish. I don't know either. So that the expression are equal on both sides. Okay, if you don't know what does it mean, it doesn't matter. Let's go with something simpler. Do you know what's that? No?
It's an equation showing two sides. One side has two variables given the other number. When you square them, the result always involves the first number squared, then adding two of the product of the two numbers, and then the square of the other number.
Okay. Any other guesses?
When you keep in mind, when you use when you want to manipulate in a certain way, use something similar to that.
Okay. Any other guesses? What's that? What does it represent? The key here is what does it represent? No? Okay, let's go with something simpler. Don't worry. No bad answer. You know that? Pythagorean theorem. Yeah. So what does it represent?
Pythagoras theorem.
Go ahead. No bad answers. No bad answers. Just whatever pops up into your mind. how to find the length of a triangle. That is what it represents. I mean, it's nonsense. C squared equals A squared plus B squared. It's nonsense. But if you have the image, then oh, if I have two sides, then I can get the other one. And if I understand how to manipulate, as you mentioned, this thing, if I have C and A, then I can get B. If I have B and C, I can get A. That is what they are useful for. Let's go with something simpler. Please do not read what's on the top of the screen. What's going on in here? Tell me what I'm representing here.
Addition.
Addition. Yeah. Any other? Any other guesses?
Multiplication.
Multiplication. Yeah. No.
Subtraction.
Subtraction. How about I say j'ai du pain et la du pain, combien de pain ça vaut? You understand that? That's French. How about namen sawa duge, kunyonen sawa duge, koinen myot kie sawa ga is nayo. What does that mean? That's Korean. That's Korean. So did you understand what I said?
No.
How about that? You understand it? What's that? 2 plus 2 equals 4. Where are you from? Peru. Do you understand it?
Yes, it's addition.
Where are you from?
Ethiopia.
Ethiopia. How about you? You get it? Colombia? Colombia, Peru, Ethiopia. I mean, we know English, but 3 countries right there understand that thing, even though I mentioned it in image, Korean, ink, and French. But there was a language that you were able to understand, and you two mentioned that. At the end of the day, math is a language. Math is the way that we model reality, and math is the way that we understand the world. And if we know how to tweak it and how to interact with it, then you can solve almost anything. Almost. Quantum mechanics, that's possible. Don't worry about that. There's people worrying about that. So, what I want you to understand and what I want you to learn from this is that maths, I know that you love maths, so this is not like something that I have to be very pushy about, but maths at the end of the day, it's just a new language. As I can communicate a bit, because I do not know that much of Korean, I can communicate a bit with Korean people because I know the language. If I put my effort in maths, I can understand math at a level that even though I'm not a business major or I don't have knowledge in revenue, I can understand an equation of, hey, my income is this one, my operational cost is this one, so 2 plus 2 equals 4. And I can get the revenue, I can know what's going on. That's why I was asking you for your interest, so I can relate to other topics. So I'll divert onto that. Do you have any questions of this? No? Math is a language. Math is not there to be hard. It's hard sometimes. I mean, this is easy for most of you or for all of you. This is easy. These ones might be hard, even for me. To be honest, don't tell my director of career, I don't know how to solve the integrals. I never did. I don't know. I don't know how to solve them, but there's a calculator that can do it for me, so I don't care. But at the end of the day, this just means something. How about, let's take, which one? Cosine x plus pi over 2 is equal to negative sine of x. You know what that could mean?
I've seen it manipulating a graph calculator on my computer. It has something to do, I think, with the way the cosine and sine are related with each other.
Okay,
Like with the
open
angles
this.
of a triangle and a circle.
Let's open this. Yeah. Cosine of x plus pi over 2 is equal to yeah, there we go. So this is the same as minus sine of x. I mean, it's the same. You can see it over there. But what does the cosine of x plus pi over 2 means? You know that? No?
let's just start with the simplest one when x is 0. When x is 0, cosine is pi over 2 would mean 90 cosine of 90 degrees, which is 0.
Okay.
If let's say we make x pi over 2 also, if we add pi over 2 and pi over 2, we get pi cosine of pi is cosine of 180 degrees, which is minus 1.
Yeah,
And then sine of the negative sine of 90 degrees is also minus 1.
okay.
And that's how they're equal to each other, how the relation actually works. I might take too long to explain, but I think the sine of x is the derivative of sine of x is cosine of x, then because the rate of change happens to be the same. I've seen people explain it, but I can't explain it.
Okay, that's totally fine. Actually, it's way more complex than I was expecting an answer, but it's okay. You want a Rice Krispie? Here you go. Okay, so that's a good answer. Actually, that's the technical answer. But I was thinking more about what does the cosine of x plus pi over 2 can mean. Have you ever turned off the music? Yeah. You know that the music is just waves. It's just you're sending an electrical impulse to a membrane on your earphone, and then that vibrates. It moves around air. So at the end of the day, it's just a wave. That's a wave. So if you want to get to move the volume, what would you do? In this case, if you understand what's going on. Okay.
Amplitude.
Amplitude. Yeah. How we change the amplitude here? Well, we just multiply it. Okay. So the volume now it's 1. I want it to be 2. So I'll just crank it up. 6, 10. I'm manipulating reality. This is music. So more effort to get a higher amplitude. And the other thing that I can make is like delay. For example, to x, that's adding a delay. Well, that's shrinking a little bit the curve. That's that's adding a higher frequency to it. So this is 2 in one unit. I'm getting twice as much, and here I put x and I'm moving it around. So what I want you to understand is not how to manipulate that thing, but just for you to understand that this is not representing what does x value is. You're representing something real. Hey, I want to turn off the volume. How do I do it? Then you have to take all the knowledge that you have to create a device, which is like an earphone, which you can manipulate reality with using that. So that is effectively what I want you to learn with. Okay, so we can conclude that math is a language. How about this? Do you know what's going on the screen? What's this? What? Aerodynamics, physics, yeah. What else? Any other idea? No bad answers. There you go. Any idea? So the image on top is turbulent flow. The image under that, like in the tubes, laminar flow. Do you know what those terms are? I'm gonna put a video. So when you have laminar flow, everything is flowing. And when I'm saying flowing, I'm speaking of fluids. What's a fluid? You know what's a fluid? Go ahead.
Fluids can be, for examples of fluid could be air, water. They have the ability to respond to a force.
Okay.
And change it. That's what I mean.
Yeah. Yeah, okay. Okay, so fluids, yeah, actually it's anything that can run. That means air, honey, I don't know, oil, whatever liquid or gas, it's a fluid. If it flows, it's a fluid. So this is laminar flow, so I'm gonna get the trick tube. We have to do. I mean, So first we have turbulent flow, and when everything is just moving like standing, that's laminar flow. Okay. I'm gonna explain a little bit more into that. Did you know that the world is lazy? Like everything in this universe, it's lazy. It's called like the universe and the reality just want to take the shortest and easiest path to do something. That is called the minimal state of minimal energy state. So everything is going to tend to the way that it's easier to flow. Yep.
Ground level?
What?
Ground energy state. That's what I heard. It's ground state or something.
Yeah, it's minimal state, it's called, but why minimal state? What needs to happen to keep this like flowing here? Okay.
A force equal and opposite to gravity.
Okay, but why like the minimal state of energy is just hanging in the ground. I don't have to, I mean, if I want to keep this here, I need to leave my hand here and I need to make it forwards and stay all the way. You want to add something? Okay, forward. So the minimal state of energy is how, like, literally, the world, the universe is lazy. They don't want to do things, and that everything in this world will tend to a way which is easier to be. That is like what laminar flow is. It's easier for that liquid to flow just in a straight line, not interrupting with each other. But then if there are disturbances, that could be changed by pressure, velocity, and many other things. Then you will have another result. But at the end of the day, the world is lazy. That is a takeaway that I want to know. Okay. Also, in here we have like an equation that it does not matter what it means, but it's just density times change of velocity over time plus velocity times the delta or the change of velocity is equal to the change in pressure plus density times gravity plus a coefficient. So it does not matter, but what I want you to get out of this is what it rules the hydrodynamics. Like aerodynamics, hydrodynamics, same thing. Air and water. It's the same at the end of the day. But these are the governing equations. What's a governing equation? What's a governing equation? Any ideas? No? So governing equations is a rule book. Like it's what tells you how anything behaves. There are the Maxwell equations. Those Maxwell equations tell us how does the electromagnetic fields and electricity is behaving. We have a Kepler law. That means how planets orbit around each other. We have a ton of governing equations, but in the realm of hydrodynamics, we have these ones. So it will be important. I might be running around in circles. Don't worry about that. What about the heart? What do you know about the heart?
It's a vertical organ.
It pumps blood. Okay.
Also oxygen.
What?
Also oxygen.
Oxygen. Yeah, all oxygen. Any other guess? It works with electricity. Any other guess?
It has the same law as what you showed earlier.
Law?
The fluid law which you showed.
Yes.
Is the same one
Yes,
as.
yes, it does. Even though the heart, it's a biological thing, something that, I mean, you don't see it here inside. You know the size of a heart? It's a fist. And it's located at you draw a line at the half of your body, and then you move it a little bit to the right, and there's your heart. That's the size of your heart. Just a fist. This thing gives you a life, and this thing inside your brain. Yeah, it relates to it. Nice catch. That's what I want. Why I said that that's what I want? Because I want you to relate concepts between disciplines. I mean, let's talk a little bit about planes. Do you like planes? Anybody likes planes? You like planes. You like X-rays. You like planes. What do you know about planes?
planes to be the most aerodynamic and also to not fall because they can't work too well without motor. Well, I studied more about jets and planes, and I know that well, in a group of stealth planes, they are like for that they are built, it's like they have to be in a certain way for the radars to not detect them. And also they have a lot of aerodynamics because of the electronics they have most in combat.
Okay, yeah, that's a good one. Everybody's got it. Maybe you are amazing at everyone. Get one. You also get one. And we need one. There you go. Yeah. So, I also love planes, to be honest. I can talk about that maybe. So, remember laminar turbulent flow? That's for the heart, but it's also for like shooting, like something, and it's also related to planes. Like, why laminar turbulent flow? You know what's this? That's a aero
DNA?
profile. Huh?
DNA?
No. This is an aero profile. I mean, this can be difficult to graph up, but this will be very useful in your life. Imagine that you extend this surface a lot, and then what you have is the wing of a plane. So this is, if you cut this in half and you see just that portion, that is what you see. That's an aero profile. That's something that is very studied, and scientists and engineers know that that thing is what makes planes fly. Why? Why? Because, I mean, what if I have a bunch of molecules of air trying to get to that part? Okay, so let's take this minimal state. So what is the minimal state here? What it's going to do is follow the path that is in front of us. So it will follow this path, which is the minimal state. And what about this? The same, but it has to be a little bit under because there's a little layer of air behind it. So then keep it. We got another one. What about the other one? How about this one? I mean, it's gonna be a little bit hard. Oh, it's impacting, and it might go this way, it might go this way. So if it goes this way, there you have a curve. So people will try to go that way, that way. That way, what happens here? You're changing reality. You're changing pressure over here. Air is moving fast. Well, I don't remember where it's moving fast and where it's slow, but air is moving fast and slow in one side, which create a difference in pressures, which effectively creates lift. And this is relatable to the heart, and you will see it in a moment. I'm going to ask you a question about it. Have you noticed what happened when you were landing here in Dulles or Regan or BWI? What happened to that wing? Did you notice? Yeah. It's called flaps. The flaps were deployed. So in this case, there were some little thingies that were turned up, and what happened is that the air is going this way, so you're generating less lift. Therefore, you are not getting up. How to explain that? Okay, so what if I take the chair and this thing? If I want to move that way, then I have to push, make an effort. It's going to be hard to move at the same speed. And what about if I don't have anything? Then I can move at the same speed and nothing's happening. Well, that's what the flaps are creating. If I put something between the air and the plane, then it will be harder. I have to make more effort in order to generate the same energy. That is the same. That is also applicable for running. I love running. So if you want to get faster, then you have to get to do more effort. And if you do more effort, you are expending more energy. But if you do something without changing other things, then you're getting less in result. So if I run 1K, I might do it in, I don't know, 5 minutes, and if I do 2K, then I'm doing each K at 6 minutes a kilometer. So I'm getting things as a change. Yeah?
If I could like two chairs, one like in front of the other and I put it at the same velocity, the chair that is behind the chair on the front will need less effort to go at the same speed that the chair that is in front because of the resistance.
Okay.
Because I saw that on Formula One, something like the resistance, a car that is in front and one that is behind, they can surpass the one that is in front.
Oh, I
because of
understand
the
what you're
resistance.
talking about. Yeah. Well, we're getting into aerodynamics that are a bit complex. In Spanish it's called rebufo. I don't know how to call it in English, to be honest. But what's happening in, let's go to Formula One. I love Formula One too. As I mentioned, I know several topics, so I can jump around. Okay, let's go. Cars. Forget about planes. So this is the one car. Sorry, I'm not good at parts. Go with me, So, in this case, what's happening here is coming, and it will try to follow this path, and this path. In this case, you are having air here, disturbances. There's a chair, like effectively there's a chair in front of the car. It's air, but it's something that is stopping it. And but if you have a car behind, air needs time to get back to the ground. So what's happening is that another car gets here. Sorry. It's off. I know. Sorry. Well, you don't have air resisting, so it can be extrapolated to the planes. If you move the flaps, then you gain more speed. It's easier to get more speed. But if you deploy the flaps, then you're getting less speed. I'm gonna rush a bit because we're running out of time. Sorry. But yeah, let's go back to the heart. Okay, forget about heart. What happens when you drop water over a stone?
It breaks.
It breaks? What? Or what?
Like the drop breaks into the.
Yeah, when a lot of drops get to the rock, yeah. That's a good answer. Any other answer? No? Okay. We can forget about that. Just keep in mind everything that I'm saying. I know that it might look like I'm just jumping around without a purpose, but I'm not doing it. Let's go. I'm a biomedical engineer major. Like that's my bachelor's, and this is one of the projects that I made. So, as I mentioned you, it's not just about one thing. You mentioned that you don't like, Sharon, you mentioned that you don't like the S and the M. Well, actually, in reality, the S, the T, the E, the EA, the M are needed between each other. Effectively, IMU and local project and STEAM are used in a multidisciplinary teams in reality. So it's not just about, hey, I'm doing engineering, I don't care about maths. Hey, I'm doing, I don't know, arts, I don't care about maths. You do care, and you will encounter that. In animation, you know how animation is made? Animation is made by programming. You need to program reality into that movie. So everything is useful. In this case, this was a sixth semester class. So in order for me to understand what's going on and understand it, like just the tip of the iceberg, I need to get cardiology, neurology, anatomy, biochemistry, computer fluid dynamics, CAD design, medicine, engineering, fluid dynamics, mechanics. Like, I mean, I need to spend 3 years of my life in different fields just to pull out these images. That is the level of these multidisciplinary things that have to be made. I mean, I'm not an expert in most of those things, but I understand them. What I want you to, I'm not going to explain what's going on, but because that's why we create these graphics. Like also a quick shout out to my partners. This is not my job. This is a published paper, but it's not just my job. My friend Adolfo and Grado are part of this project, so shout out to them. And I want you to, like, tell me what's going on. Look at this. Look at this and tell me what's going on. I'm not giving you context, but just try to explain what's happening.
You're looking for a way to go out?
You're looking for a way to go out. Yeah. Any other guess? What?
They are spreading.
Spreading.
Como expresarse.
Okay, yeah. The fluid is spreading, dispersing. I don't know. Any other guess? No? I'm gonna give you more pictures. I have a bunch of them. How about this one? What do you see in different? I mean, you see here most 10, 3 millimeters, 6.5 millimeters. What do you get out of that? Let me know. I want you to analyze things. Most of the times we don't know what's happening. You're being scientist right now. Like, what does a scientist do? A scientist observe. No, go ahead.
Gather information, organize the information, make useful insights out of the information, take the insights and make a conclusion, then present the conclusion, and then maybe even apply it for something that you might be wanting to use it for.
Totally correct. That is totally correct answer. Right now, I want you to be scientists. You are scientists. Gather the information that I gave you through this class so far, and now try to explain what's going on. Analyze the data. If you want me to change the picture, I can show you more pictures. I have, like, I'm not joking, 60 images of this. I have
Can you show
videos.
some more pictures?
Huh?
Can you show some more
Yeah,
pictures?
sure. Which one do you want? Let me know which one do you want.
Yeah, can you stop there?
This one?
Yeah, just give us some time to
Okay. You're being scientists. Take it real. There is no wrong answers. A failed hypothesis, a null hypothesis, it's a good hypothesis. It's generating knowledge. Just try to understand. I mentioned you. Okay, the heart is a chamber which pumps blood. Okay, the stone. Where's the stone? Where's the droplet? Okay, where's the airplane? Where's the air? Where's turbulent flow? Where is not turbulent flow? Try to wrap up your mind on those topics. I mentioned you like the clues that you need. Okay?
I want to take a guess.
Wait, let's.
Yeah.
Yeah, you first.
Okay. I don't know if the relation is correct, but I think in the three cases with no stent, the pressure under the blood is more higher than the others. With the other, in 3 and 6.5, the pressure is less. The pressure under the blood.
Okay. That's a good guess. How about you?
So, like how a plane has a flap, a stent is a flap, is what I'm guessing. And the blood is flowing, and you have put a flap to put the to reduce the force of the blood, so that it becomes easier to the vessel, maybe.
Okay. Good guesses. Do you have another guess? Whatever you want. No wrong answers. I mean, this is very like high level. I mean, this is a university project which is published in a research journal, so it's a big deal. Just go ahead. Any other guesses? No? Okay. Try to find the rock. I'm not going to say anything about the rock, but try to find the rock and the water. Yeah, I'm going to explain you the context of this. So, what I did here, this is the walkthrough. This is for you. This is the walkthrough of how the project was conceived. First of all, you have a patient with has an issue. In this case, an aortic aneurysm, and I have a picture for that. So, an aortic aneurysm is just a balloon, a deformation or something that it's growing and it's supposed not to be there. And what it's made, it's a TEVAR, thoracic endovascular repair. So what that means is that they put a wire on your heart, or well, not your heart, in your blood vessels, and then you seal the exit. Like, this is just like a tunnel. Instead of flowing through that big balloon, which creates turbulent flow, you flow through the tube, like mesh, and then it's easier for the blood to move. That is what's happening here. Let me see something else. Whoa. If you want this graphic, I can give it to you. Like, it's a school project, but I don't care to share it with you. So what happens is that we took a patient, put it in the CT scan, then I got images. After getting the images, I was in charge of pre-processing, processing, and designing the aortic arc. I have a 3D model out of that. I can not show you here. But this simulation was run in that computer. It's dying. Help me to university. Cheers to that computer. But after that, we understand the governing equations that play with. After that, we understand the governing equations that we had, and then we make guesses with the information that we have, we analyze the information, and say something. Okay, you mentioned the flap. Do you see the flap? Where's the flap? You have the flap, like a wing. There is a wing.
It's the light brown color.
Oh my God. What's happening with this? Do you see the airplane wing here? There's an airplane wing. The blue. Do you see the blue? Yeah. The blue thing looks quite similar on aero profile. I mean, what's going on with that? You see that? It's there. It's the same. Like the same shape. Why? Why do you think?
Where is it?
The blue part? Like in here, you see the mouse? You see that blue part? It looks like a wing, like from a wing of a plane. What's happening is that there's a flap. What's the flap? The flap is called Bird-Beak. You see the red line? That red line is a Bird-Beak configuration. It's a tail stem procedure. That means that thing does not stick to the blood vessel, therefore it's failure. So if you get a shape like this, which is like a Bird-Beak, that's the reality. It's a Bird-Beak. That's why they call it Bird-Beak. And it's a failed surgery. And after that, what we wanted to know, the question was, what happened if the failure is more severe? Instead of 3 millimeters, it's 6.5 millimeters. And in this case, let me see the 10 minutes. And in this case, what we had to do is take all this image, analyze what's going on. To be honest, it's not important to know what's the answer out of this. Like, it's quite evident that it's getting worse as the length is longer. But what I want you to understand is that you take other fields, other knowledge, other language to understand what's going on. What's going on here is that the Bird-Beak configuration is effectively a flap that is impeding the air to the blood to move around. So we have the aortic arch, and then we have the stem, which is this, and we have a small gap that is protruding here, which is making the blood to protrude. Yeah, there. Like the black parts are blood that is just not moving. So we are getting a flap over there that is impeding the blood to flow. That is what's happening. I want you wrap up the stone. Do you see the stone here? Like the droplet of water with the stone? It's there. I promise. What happens when a drop of water goes through a stone many, many times?
It's like
You break the stone. Where is it breaking? Okay, I forgot to teach you this. Okay. Why blue is cold and red is hot? Like,
Blue is considered cold because it's related with water. Because the sky actually is blue, and then when the sky's light gets into water and reflects back, it has a distinctive blue color when it enters space. Well, if you see regular water, it doesn't have that blue. And red is associated with heat because fire is, which is fire, lava, basically infrared, is related with is what you observe when these are in place.
okay. Not the answer I was looking for. It's a good answer. Like, I mean, it makes sense. What I want is, okay. How are your hands? Like, they're feeling cold or what? Like warm, like normal. What if you put them together? Remove them.
Friction.
Friction, there's heat. So, temperature or heat or any magnitude, when you have more of something, we tend to use them as red, and when you have less of something, we tend to use it as blue. It's just aesthetics, but at the end, what I want you to understand out of this is like, in temperature, it's the movements of particles. You know, this is at, I don't know, 200 degrees Celsius, so it's moving really fast. But if I put it in the freezer, it's going to stop moving until the point where this is just stationary. This is when you get to zero. When something is not moving, it's the absolute zero. I think it's negative 270 Kelvin. I don't remember that.
Minus 273.15.
He knows it. But okay, so what I want you to understand from this is that when you have less of something, you're cold. When you have more of something, you're hot. Where are you having more of something in that image? Analyze it, please. I'm gonna give you a hint. There's something in 3 and 6.5 that you don't have in notes yet. There is something.
A lady in red.
There is something. Here. What's going on here? What is that? It was the conclusion that we made. It's,
Están espantando.
yeah?
Están espantando.
No. What is happening here is that there's something that's impeding the movement of the blood freely, and what's happening is that blood is being perturbed and in a turbulent manner, and it's impacting in that little dot, like the red dot, like single dot here and here. There is your stone. There is your stone. So blood is impacting and impacting and impacting and impacting. You know how many bits you make a minute?
70.
Yeah, from 70 to 80, that's normal. If you are running or you are doing exercise, you go up, you can ramp up to 200 maybe. So imagine 200 droplets of water impacting on the aortic arc of your vessel. Then you get trouble because that can break. As rock blade break, you can break it here. And I mean, if I was talking about the rock, I was talking about the plane, I was talking about Korean, I was talking about many things. But at the end of the day, it's just getting information from different backgrounds and put the whole picture together. I mean, I know it's not, this class is not, because we need to finish soon. I know this class is not about learning a hard topic, but to understand how to take the pieces of the puzzle, which is science, and to put them together to understand the topic. This is a highly, highly advanced topic. I mean, it's medicine. From that part, I'm not good at medicine. I almost failed that subject. I'm good at engineering. I'm good at CFD, which is computer fluid dynamics. But my takeaway for this class, and I'm going to ask you at home, my takeaway is for you to question everything that you have in front, to know that there are not dumb questions, that there are not dumb hypotheses, and what you need to do at the end of the day is to be curious. And also, it is not important the solution. I can get you the number of how much Pascals are in that red dot, but I mean, that's not necessary. The important part for us, the scientific method that we follow and how we are conducting it. Do not memorize things. At the end of the day, that's not you. As an engineer, what I value the most is the thought process. And I think your teachers back in your country will be really happy if you value the thought process at the end of the day. Not only the answer. The answer is not important, and for me at least, that's also for life. It's not important what you achieve. The important thing is how the journey that you get to achieve that thing. Because if I understand the journey of blood, I mean, I can tell the doctor, hey, you screw it up. I mean, that patient is gonna die if you don't do something. That is not important. But if we understand what's going on, then okay, we have to make changes here, there, and that won't happen again. Fail the most that you want to get great results. That is the summary of my class. I mean, we are effectively ending it. I hope that you really like it. Please let me know if you have any questions, if you want to approach me or whatever, please go ahead. I know it's not the science class that you would expect out of a summer camp, but that is something that I wanted to teach you. And any comment, any question? Thank you. Don't worry. Same thing? Or you're good?
No, this is business, this is the same, se hace cada semana.
Ah, sí. Oh, yeah.